In this lesson, we're going to go over analyzing arguments. Our objectives today are to learn about the two different types of reasoning that we'll talk about in this class. We'll construct a Venn diagram to analyze a deductive argument, and then we'll determine whether an argument is valid and or sound. So inductive reasoning goes from specific facts or assumptions, to a broader general conclusion. So for instance, you observe or you know 3 facts: bluebirds fly, hummingbirds fly, cardinals fly. The conclusion, the more general conclusion, all birds fly. Okay, what do you do with this ostrich over here who doesn't fly? But this is taking specific examples and going to a general conclusion. Another way I like to think of inductive reasoning is kid logic. If you've been around little ones, this is how they start to make sense of the world, where they see a couple of examples of something and they make a general conclusion. So I was working with, I think the child was about 3 or 4, and we were in a classroom, and 2 of his teachers were named Tina. So we have teacher 1 is Tina, teacher 2 is Tina. Third teacher walks in the room. Of course, the kid concludes, "Are you Tina as well?" His other 2 teachers are named Tina, so this third teacher has to be named Tina as well. So that's an example of inductive reasoning. The way to evaluate an inductive argument is based on its strength or weakness, is how we talk about these arguments. So they don't necessarily prove the conclusion to be true, so we look at how strong they are or how weak they are. An argument is strong if a compelling case is made for the conclusion. Typically, a lot of examples or premises are needed to go from specific to general to make a strong case. An argument is weak if the conclusion is not well supported by the premises. So in the last example, just knowing that 3 types of birds fly doesn't make a good case for saying that all birds fly. The next type of reasoning is deductive reasoning. It goes the other way. This goes from general to specific. So for instance, you have a premise: all doctors are intelligent. That word "all" is telling us we're talking about something broad or general here. Another premise: Dr. Oz is a doctor. Conclusion: Dr. Oz is intelligent. So with this type of argument, it follows from the 2 premises, one of them being very general, to form the conclusion. Now, when we evaluate deductive arguments, they're evaluated based on if they're valid or sound. So these are the 2 criteria that we'll use. An argument is valid if its conclusion follows necessarily from the premises. So the premises don't necessarily have to be true for an argument to be considered valid. It's an objective stance on the argument, whether the conclusion follows or not. If the conclusion doesn't follow, it's called not valid. The other criteria that we'll use is sound. So an argument is sound if, one, it has to be valid. So first of all, in order to say an argument is sound, it must be valid, and all the premises must be true. Okay? So if an argument is valid, but one of the premises is not true, it's not sound. Or automatically, an argument that's invalid or not valid is automatically not sound. Okay, so your options are not valid, not sound, but if the argument is valid, it could be sound or not sound depending on the truth of the premises. So what we'll do is we'll learn to use Venn diagrams, specifically subset Venn diagrams, to test the validity of arguments. So what we'll be able to do is we'll draw a Venn diagram that represents the information we're given, and then we'll be able to use the Venn diagram to see if it confirms the conclusion or not, which will help us determine the validity of the argument. Okay, so we'll go through 4 examples. So example 1, construct a Venn diagram to test the validity of the deductive argument. Use X to represent whales. So what we're going to do here is we have 2 premises and a conclusion. Premise 1 allows us to construct the subset Venn diagram. Premise 2 allows us to draw X to represent whatever we're told to represent. So in this case, it's whales. And what we'll do then is we'll compare where X is located on the Venn diagram with the conclusion to determine whether the argument is valid or sound. So note that we're not doing anything in terms of like X or the subset Venn diagram with the conclusion. We use the first 2 premises and see if what we drew confirms or not the conclusion. And we'll go through this. We'll talk about this again once we do this first example. Okay, so premise number 1, all fish live in water. And so I've got the subset Venn diagram here for you. You have to determine which box is fish and which box is living in water. Okay, so you've got 2 options here. You could say fish or water, or water, or fish. So let's read both of these, knowing what we know about subset Venn diagrams, to see which one the premise is actually talking about. If we look over here, this would mean all fish, because this whole thing is completely contained within the outer circle. This says all fish live in water. The other one, I should have done it in a different color. Let's use green. This would say anything that lives in water is a fish. Okay, our premise number one is talking about the first, all fish live in water. So let me erase this. This would be fish and live in water. Okay, also note that this region here in between, that's outside of the circle of fish or the set of fish, but inside the circle of water, these are other things that live in water, such as whales, shrimp, lobster, crab, whatever. There's other things that live in water that are not fish. And then in this region in between the whole box and the set of things that live in water would be things that don't live in water, okay? So premise number one, this is how we were able, I'll circle it in blue, that's how we were able to construct the subset Venn diagram. Premise number two is where we're going to draw our X. Okay? And so from premise number two, it's telling us that whales are not fish. But which means that whales could be anywhere outside of this circle of fish. And so what I like to think about is there's really three regions of this Venn diagram. Region 1, which represents everything here. Region 2, which is here. And region 3, which is everything here. Okay, so when it says whales are not fish, all we know is that it's outside of the purple region or region 3. It's not telling us whether it's in region 1 or 2 or not. It could be either based on that premise. Okay, so you're just looking at the premise, whales are not fish. Since it could be in region 1 or region 2, it would be on the border of region 1 and 2. Okay, all we know is that it's not fish, so that our X that's representing whales cannot be in circle 3, but from the premise, it's unclear whether it's in region 1 or region 2. Okay, so those two, so again, first premise allows us to construct the subset Venn diagram. Premise 2 allows us to draw X, and now what we're going to do is we're going to check if the argument is valid. Okay, so the conclusion is whales do not live in water. So what we're doing is we're matching up this conclusion with this value with where X is located. Okay, so note that X is on the border of living in water and not living in water because premise 2 wasn't clear. So in this case, the argument is not valid. Because X is not within this circle of living in water, we cannot confirm the conclusion. Okay, or the conclusion doesn't follow. An argument that's not valid is automatically not sound. So this argument is not valid and it's not sound. We'll keep going through additional examples. Example 2, construct a Venn diagram to represent the validity of the deductive argument. Use X to represent Carlos. Okay, if a person lives in Chicago, then the person likes windy days. Premise 2, Carlos lives in Chicago. Conclusion, Carlos likes windy days. So premise 1 allows us to construct the subset Venn diagram and determine which way it's talking about. In this case, if they live in Chicago, then they like windy days. There are people that don't live in Chicago that like windy days as well. Okay. Premise number 2, Carlos lives in Chicago. And again, I'm going to break this up into 3 regions. Region 1 is people who don't like windy days. Region 2 is people who like windy days but don't live in Chicago. And region 3 are people who live in Chicago, which means they like windy days because of the subset Venn diagram. If you go back to the previous lesson on Venn diagrams, this is where we had said all whales are mammals. This is saying all people that live in Chicago like windy days. Okay, so premise 2 is what's going to allow us to draw our X. Premise 2 is Carlos lives in Chicago. Here's our live in Chicago, the set of people who live in Chicago. Carlos is a member of that set because it's saying that Carlos lives in Chicago. Okay? So this was 2 that allowed us to draw X. And now we talk about, is it valid? Okay, so the conclusion is Carlos likes windy days. So based on the location of X, is the conclusion true? Well, Carlos lives in Chicago, and people who live in Chicago like windy days. So yes, this is valid because the conclusion follows necessarily. Now let's talk about sound. Okay, remember that a valid argument could be sound or not sound. In this case, I would probably say it's not sound because of premise 1. I don't think it's true that all people who live in Chicago like windy days. So that premise, because it's not true, makes the argument not sound. But again, because of where X is located, X supports the conclusion based on the Venn diagram, the argument would be valid. Next example, we're using X to represent aspirin. So we have a narcotic is habit forming, aspirin is not habit forming, aspirin is not a narcotic. So again, premise 1 allows us to construct the Venn diagram. So here we have a narcotic is habit forming. And what I would say with this is, if you're not sure which way to label the inner or the subset of the outer set, is try both ways and read it back to yourself using those categorical propositions we talked about. And when you read it to yourself, make sure it matches what the premise is saying. Is it saying anything that's habit forming is a narcotic, or is it saying all narcotics are habit forming? Okay, a narcotic is habit forming, so that's why it's in the subset circle. And then the outer circle is things that are habit forming. Okay? There's other things that are habit forming as well. And so next, premise aspirin is not habit forming. So I like to put these numbers here. I hope they're helpful to talk about the regions we have of this Venn diagram, where region 1 are things that are not habit forming because it's completely outside of that set. Region 2 is something that's habit forming but not a narcotic. And then region 3 are narcotics. Okay, so premise 2, aspirin is not habit forming. So our X would go in region 1 because that's outside of the set of things that are habit forming. Premise 2 is saying aspirin is not habit forming. X goes outside of that. Okay, and now we check, is it valid and is it sound? Okay, aspirin is not a narcotic. So take a look where X is. X is completely outside of the circle of narcotics. It's not even touching that circle. If it were on the border, we would have to look at it a little bit differently, but it's completely outside of the circle. So this argument is valid. And then we check to see if it's sound, because remember, a valid argument could be sound or not sound. Okay, in this case, I would probably say it's sound. You may disagree if you do think that aspirin is habit forming. If this were to be asked on an exam, it would be clear if the premises are true or not. And the last example that we'll talk about is this should say use X to represent Jake. Okay, and so premise 1, all dogs are smart. So we have dogs, smart. We have things that are not dogs that are smart, like you all that are in my class. Okay. Jake is smart. Okay, so let me label the regions again, 1, 2, 3. So it's saying Jake is smart, but it's not commenting on whether Jake is a dog or not. Again, we're just on premise 2 to draw the X. So it's saying Jake is smart. We're not sure if it's here or here, so the X would go on the border if it's not clear. If it could be in 1 or 2 of these regions that I've been describing, it goes on the border of the 2 regions it could be between. Okay, so all it's saying is Jake is smart. That means Jake is somewhere in this circle, but since we don't know if Jake is part of the subset or not, it goes on the border. Okay. And then now we check to see if it's valid or sound. Okay. And so conclusion, Jake is a dog. So we take a look here. We're not sure because X is on the border. It's not definitive whether Jake is a dog or not. So this would be not valid, which automatically makes it not sound. Okay. If you have any questions about this, please feel free to reach out to me.